Hello everyone, welcome to my channel. In this video we are going to discuss about logarithms and we'll see how these logarithms are related to exponents. We'll also discuss about the properties of logarithms. Let's get started. First, we know the exponents. A number, say b, is raised to certain power, say y, will get a value, certain value will get, say x. So this I can write like b raised to power y is equal to x. This we know, this is the my exponent form. So for example, I'll take 2 raised to power 3. We know it, this means that we are multiplying 2 3 times is always equal to 8. Now let's see what is the meaning of logarithms. Actually, the logarithms are the inverse function of exponent. Logarithm of a positive real number x with respect to base is the exponent by which b must be raised to get x. We write this logarithm as log. This base is right here and this x I will write here, and which is equal to the exponent by which b must be raised to get x. So that exponent here c is y. We can write this as in exponent form like this. b raised to power y is equal to x. Or we can write this equation also in logarithmic form. How we can write this? We can write this as log of which this 8 base 2 is always equal to this exponent 3. Okay, here we know this b is the base, b is known as base. What is this x? X is my argument. And what is this y? Y is my exponent or power, we can say. So this is my logarithmic equation, and read this equation as logarithm of x at base b is y. Here x, b, y are real numbers such that x and b are greater than 0, and b is should not be equal to 0 and b should not be equal to 1. So to know more about logarithms or logs, let's take few examples and we can see how we can change logarithmic form into an exponential form and an exponential form to a logarithmic form. So in this question we know this 8 is my base and this is my power. So I can write this as 8 raised to power minus 1, which is will be equal to this 0.125. So this is my answer. So in second question we have this question in exponential form. So we can convert this into the logarithmic form. Like we know this is base, 5 is base and this is 125. So this will become log base 5 log of 125 at base 5 is equal to 3. And third question is, we can write this in exponential form. This is base a raised to power x is equal to this a. And here logarithmic form we can write this as log of this 27 at base 81 is equal to 3/4. This is all about the basic concept about logarithms, and they tell us that the logarithm of any positive real number with respect to a base is always equal to the exponent by which we must raise the base to get our positive real number. Two special logarithms. These are, first we have these common logarithms. These are the logs with base 10. So we can write like this: log of 51 base 10. So we for these logs no need to write base. So we can simply write log 51. Okay, whenever you find any log without any base, it means that that log has a base 10. Okay. So next we have natural logarithms. Next we have natural logarithms. These are the logs with base e, Euler's number, and the value of Euler's number is e is equal to 2.71828. This is its value, and we write these natural log as log of 51 with base e. So simply we can write these as log n, natural log. No need to write this e51. Next we will discuss about the laws of logarithms. First we have product law. According to this, the log of m into n base a is equal to log m a base a plus log n a. This is my product law. Second is quotient law. According to this, log m divided by n base a is equal to log m base a minus log n base a. So third is power law. According to this, log m raised to power n base a is equal to this n. I will write here log of n, log of m base a. So next we have change of base. Here log a base b is equal to, now I will take another number c. So this will become equal to log a base c divided by log, this b will come here, log b base c. So next we have equality law. According to this, log of a base b is equal to log c base b. Means base, both the side, left hand side and right hand side are equal. Then we can say that this a is equal to c. Next we have number raised to log. Means we have a number and its power is in the form of log with same base as the number a. See here a. Then the a raised to power log of x base a is equal to x. So for example, if I take a log a raised to power n m plus log a n. So this we can write like this. A, we know this first rule I will apply here. This will become m into n, correct? So this will become here this number and this base are same. So this will become m into n. So next we have log of 1. Log 1 base a is always equal to 0. Any base is there, we know. If we change this in exponential form, we will get a raised to power 0 is equal to 1. So if we have this 1, the log of 1 is always equal. So we can say that the log of 1 is always equal to 1. Sorry, the log, so we can say that the log of 1 with any base is always equal to 0. Next we have the log of same number as base. For example, the log of a base a is always equal to 1. So let me take one example. The log of 5. Log of 5 base 5 is always equal to 1. You can prove this. You can change this into the exponential form. This will become 5 raised to power 1 is equal to 5. So next we have the log of 0 base, any base is always undefined. Why so? If I take For example, log of 0 base this is equal to x. So this will become b raised to power x is equal to 0, which is not possible. So we can say that this log is always undefined. We have the log of a base b is always equal to 1 divided by, if we interchange these two numbers, log a log of b base a. So this we can say the log of 5 base 2 is always equal to 1 divided by log of 2 base 5. So next law we have the log of a raised to power m base b raised to power n is equal to, we will take this power here, m divided by n log of a base b. So next we have negative log of a base b is equal to log of 1 by a base b, or log a base is 1 by b. And this is all about the laws of logarithms. In next video, we'll discuss how we can use these laws to expand and condense our equations. So try to remember all these rules. So thank you everyone for watching my video.